Hey everybody, we're doing our second of 3 days of trig now. This is assignment 18. And I want to go back and review some of our basic trig stuff. Um, this was stuff we would have done in January of 2020 in trig class. First is I want to think about, well, I kind of really want to think about this. Hey, remember your unit circle? Um, yeah, you really need to know your unit circle. Um, you need to have these values memorized like you had them memorized last year. Um, I would expect a unit circle quiz at any moment to come into your life. Let's just quickly review to make sure that in the last few months you haven't all forgotten your unit circle values. Okay? So over here we have root 3 over 2 1/2. And over here we have root 2 over 2 root 2 over 2. And here we have 1/2 root 3 over 2. Remember that this is 0, 1, 0. And this is 0, 1. Okay, over here at 2 pi over 3 we have negative 1/2 root 3 over 2. And here we have negative root 2 over 2 root 2 over 2. And here we have negative root 3 over 2 positive 1/2. This is negative 1, 0. When we come down here for 7 pi over 6, it's also negative root 3 over 2, but negative 1/2. Negative root 2 over 2, negative root 2 over 2. This is negative 1/2 coming in negative root 3 over 2. This is 0, negative 1. And then in quarter 4, we've got 1/2 positive x's, negative root 3 over 2, and negative y's. Here's root 2 over 2, negative root 2 over 2. And here's root 3 over 2 and negative 1/2. So those are all our coordinates, but we also need the angles in degrees and radians. We will very rarely be using degrees here, but you should know them. So this is 30 degrees, 45 degrees, 60 degrees. What did I... Oh no, that's the axis. Sorry, I was looking at it slightly sideways. So that's 0 degrees, that's 30, that's 45, that's 60, that's 90, 120, 135, 150, 180, 210, 225, 240. How did I get off? Oh no, I didn't. 270, 300, 315, and 330 degrees back to 360 degrees. So those are all my degrees. I definitely need the radians. This is 0 radians. This one is pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6. There's pi radians. This is 7 pi over 6. This is 7 pi over 4. No, 5 pi over 4 here. 4 pi over 3. This is 3 pi over 2. This is 5 pi over 3. This is 7 pi over 4. And this is 11 pi over 6. Okay, you need to be able to fill out that unit circle in under 5 minutes because you really need to have these values at hand. All right? We'll come back and do some practice with that in a few minutes. Right now, because we're talking about the unit circle, I know that on the unit circle, there's this. This is an x value, this is a y value, and the radius on the unit circle is 1. So I could have this point here, and if I plugged this x value and this y value into the Pythagorean theorem, I would get 1 coming out. Right? But what do we know? Well, if we know that x squared plus y squared equals 1 here, what's x represent with respect to theta? Well, when I think about my trig functions, adjacent over hypotenuse would be cosine. So I can replace x's with cosine thetas. And then what about y? Well, this, opposite over hypotenuse, is sine. So I can replace this y with sine squared. And this is where our first Pythagorean identity comes from. Right? It's just coming right out of the Pythagorean theorem and our knowledge of trig ratios. Cosine squared equals 1. And I mentioned in the last video that not only do you have to know this basic Pythagorean identity, but you need to know a bunch of them. So, for example, if I divide everywhere by sine squared, I'm going to have 1 plus cosine squared over sine squared, that's cotangent squared, and 1 over sine squared is cosecant squared. And likewise, if instead of dividing everywhere by sine squared, I divide everywhere by cosine squared, sine squared over cosine squared will be tangent squared. Cosine squared divided by cosine squared is 1, and 1 divided by cosine squared is secant squared. So these are the three Pythagorean identities, but I also have to recognize the rewritten versions of them, like sine squared equals 1 minus cosine squared, or cosine squared equals 1 minus sine squared, or this one. Okay. Hey, don't confuse sine squared equals 1 minus cosine squared for sine squared equals 1 minus cosine 2 theta over 2. We do need our power reducing identities, but we also need our Pythagorean identities. And how are you supposed to know whether to use this or this? Well, that's going to depend on the context of the problem. We're going to have to figure that out each time. But first, let's make sure we're clear on these other rewritten versions. I know that cotangent squared would be cosecant squared theta minus 1, or that cotangent squared minus, no, sorry, I'm moving the cotangent over there. That 1 equals cosecant squared theta minus cotangent squared theta. Okay, and then finally, the rewritten versions of this one, I got tangent squared theta equals secant squared theta minus 1, or 1 equals secant squared theta minus tangent squared theta. Okay? So these are my, I guess you could call them 9, but really I think of 3 Pythagorean identities. You know, we don't need to worry about half angle or double angle or sum and difference formulas, but like I said in the last video, we're definitely going to need 1 plus cosine 2 theta over 2, our power reducing identities, and sine squared is 1 minus cosine 2 theta over 2. Okay? Hey, for practice, why don't you do this one? Cosine squared 3x. What will that be? Okay, so remember when I use the power reducing identity, that angle doubles. So I'm going to have 1 plus cosine, the angle doubles, 6x all over 2. And I would probably split that into 2 fractions. All right? How about this one? Sine to the 4th 2x. Why don't you take a couple minutes to work through this one? And come back when you're ready to talk about it. Okay, so remember that this is sine squared 2x times sine squared 2x. And with each of these, I'm going to use this power reducing identity. 1 minus cosine, what happens to the angle? When I use the power reducing identity, the angle doubles. So this is a 4x over 2 times 1 minus cosine 4x over 2. I FOIL on top. This is often hard for people. It's cosine times cosine to make cosine squared. We don't change that 4x. Okay, it doesn't, we're not multiplying this times this, just this times this. All over 4. I'll split that into 3 fractions. I'll have 1/4 minus 1/2 cosine 4x plus 1/4 cosine squared 4x. Am I done? No, I'm not done. Why do I know I'm not done? Because I see a squared. So I have to use my power reducing identities one more time, just like we did in the last video. And that's going to be 1 plus cosine. What happens to the angle? The angle doubles over 2. So that's going to give me 1/4 minus 1/2 cosine 4x plus 1/8 plus 1/8 cosine 8x. I still have these like terms to combine, but I'm pretty much done. I hope you got this answer as well. And if not, feel free to ask me some questions or to practice this material some more, or maybe both. All right, now I'd like to do some lightning round problems. What do I mean by that? Well, I mean these problems shouldn't take us very long, so by the time I'm done writing it, you should be able to think about an answer to it, okay? Don't be pausing the video here. Just go as fast as you can. Oops. What's the sine of 0? 0. Okay, that's the angle. That's the upness. Phew, I did the first one for you. How about sine of 2 pi over 3? What's the sine of 2 pi over 3? Remember, sine is the upness, the y value at 2 pi over 3, so we have root 3 over 2. How about sine of 7 pi over 4? It's the y value at 7 pi over 4, so it's negative root 2 over 2. Okay, you need to get that answer before I'm done saying it. Hurry up. Cosine 2 pi over 3. 5, 4, 3, 2, 1. Okay, what about the sine of pi over 2? Sine of pi over 2. 5, 4, 3, 2, 1. Okay, how about the cosine of 5 pi over 6? 5, 4, 3, hurry, 2, yes, you need to know your unit circle this well, root 3 over 2. Okay, how about secant 7 pi over 4? Secant 7 pi over 4. 5, 4, 3, 2, 1. Now I know that cosine 7 pi over 4 is root 2 over 2, so secant would be 2 over root 2, and if I rationalized, I'd end up with 2 root 2 over 2, or root 2. So secant 7 pi over 4 is simply root 2. Remember, when you're writing a sentence for these in the homework, that's your sentence. Secant of 7 pi over 4 is 2, root 2. Okay? Don't forget to write sentences. Okay, if you're not getting full credit on your homework, the first thing I'm going to say is, are you writing sentences? Okay, next. Cosecant 2 pi over 3. 5, 4, 3, 2, 1. 2 over root 3, or if you rationalize, 2 root 3 over 3. Why? Because this is the reciprocal of sine, and the sine of 2 pi over 3 is root 3 over 2, so cosecant must be 2 over root 3. Secant 4 pi over 3. secant 4 pi over 3. 5, 4, 3, 2, 1. We know that cosine of 4 pi over 3 is negative 1/2. So negative 2 over 1 would be the secant of 4 pi over 3. How about the cosine of pi? 5, 4, 3, 2, 1. Exactly, negative 1. We know cosine is the x value. And the x value for pi is negative 1 on our unit circle. The secant of pi, what would that be? 5, 4, 3, 2, 1. Well, negative 1 flipped upside down is still negative 1. How about cosine pi over 2? 5, 4, 3, 2, 1 is 0. But what about secant of pi over 2? Be careful. 5, 4, 3, 2, 1. Undefined. Remember in our trig graphs in the last video, at pi over 2, the secant graph had a vertical asymptote. So I get undefined here. You could think of this as 0 over 1, adjacent over hypotenuse. So when we flip that, we have 1 over 0, and we know we can't divide by 0. That's undefined. One pizza sits on the table, and no one comes to eat the pizza. How much pizza do you have? You have an undefined amount. You might even say an infinite amount of potential. All right, what's next? Tangent pi over 4. 5, 4, 3, 2, 1. And 1 is the answer. Tangent of pi. 5, 4, 3. Remember, tangent is opposite over adjacent, so it's y's over x's. Think about the y value of pi, think about the x value of pi, and you want to do y's over x's. 3, 2, 1. The y value is 0, the x is negative 1, and so we end up with 0. How about the tangent of negative pi over 4? Ooh, the tangent of negative pi over 4. Negative angles. Yes, negative angles. So remember, negative pi over 4 is the same as tangent of 7 pi over 4. Does that help? 5, 4, 3, 2, 1. I get negative 1. Remember, all students take calculus. All students take calculus. All three trig functions are positive here. Sine is positive here. Tangent is positive here. Cosine is positive here. So if I've got tangent of something here, I know that tangent has to be negative because tangent is only positive in these quadrants. Tangent is negative in these quadrants. Okay? What's next? Cotangent. We haven't talked about cotangent yet. Cotangent of pi. 5, 4, 3, 2, 1. Hey, before I reveal, how many of you thought about the graph, the cotangent graph at pi? That's right, there's a vertical asymptote there. So this is undefined. And then we've got cotangent pi over 2, 5, 4, 3, 2, 1. Right, that's our inflection point on the cotangent graph. It's also a vertical asymptote on tangent. And then what about cotangent 3 pi over 4? If tangent is y's over x's, cotangent must be x's over y's. Okay, so 5, 4, 3, 2, 1. Well, we know that's negative root 2 over 2 over root 2 over 2, and so that's negative 1. All right, that's the end of round 1. We have 2 more rounds to get through. Here's the next one. Sine of pi over 6. 5, 4, 3, 2, 1. Sine of 5 pi over 6. 5, 4, 3, 2, 1. Now, inverse sine of 1/2. Remember, we read this as what angle has an upness of 1/2. 5, 4, 3, 2, 1. Now, why isn't the answer pi over 6 and 5 pi over 6? Because I saw each of these angles had an upness of 1/2. But the answer to the question, what angle has an upness of 1/2, is pi over 6. Because really what we're saying when we're reading this is, what angle within the restriction, the domain restriction we talked about in the last video, has an upness of 1/2. What was the restriction for inverse sine? In fact, let's take a moment to stop and write these down. Inverse sine gave us angles between negative pi over 2 and pi over 2. Inverse cosine had to be restricted differently. That was 0 to pi. And tangent inverse was the same as, was the same, kinda, as sine inverse. These are where the horizontal asymptotes are, so they can't be included. Okay? So you need to know these restrictions. So when I say sine inverse of 1/2, within this restriction, what angle has an upness of 1/2? Remember, we're talking about here, and we're talking about here. Pi over 2, negative pi over 2. We can't get to this one over here at 5 pi over 6. There's no way to get over there. So we have to only take this answer here at pi over 6. All right? So we know what angle within the restriction has an upness of 1/2 is pi over 6. Great. Now I think you're ready to move on with these. How about this one? Sine inverse negative 1. 5, 4, 3, 2, 1. Did any of you say 3 pi over 2? I hope not, because that's outside of the restriction for inverse sine. Remember, our restriction goes from negative pi over 2 to positive pi over 2. We can't get past that to choose 3 pi over 2. I know the sine is equal to negative 1 at 3 pi over 2, but I need an answer that's within the restriction, so I have to go in the other direction, and so my answer is negative pi over 2. Pay attention to those details. All right, let's see if we can pick up the pace. Cosine inverse 1/2. 5, 4, 3, 2, 1. What angle within the restriction has an x value of 1/2? Pi over 3 does. Okay. How about tangent inverse root 3 over 3? Now, with this one, either you want to unrationalize this, i.e. you're looking at something that's been rationalized, now you want to do it backwards, or why don't you rationalize the numerator? And so then you'd have 3 over 3 root 3, or 1 over root 3. Now you may be saying, I still don't recognize that, and that's reasonable. But if we divide the top by 2 and the bottom by 2, we know that sine x over cosine x would be 1/2 over root 3 over 2. So when is the sine equal to 1/2? When is the cosine equal to root 3 over 2? And remember, we're looking for an angle within the restriction for inverse tangent, and that is from negative pi over 2 to pi over 2. So when do we have this? Our answer would be for which angle? Our answer would be pi over 6, because sine is 1/2 and cosine is root 3 over 2. Okay, what's next? Cosine inverse negative root 3 over 2. 5, 4, 3, 2, 1. Well, cosine is negative root 3 over 2 at 5 pi over 6 and 7 pi over 6, but 5 pi over 6 is the answer that's within the restriction. How about sine inverse of negative root 2 over 2? 5, 4, 3, 2, 1. Did you say 7 pi over 4? I hope not, because that's wrong. Remember, we can't get past pi over 2, so how could you possibly get to 7 pi over 4? We need to come from the other direction, so our answer is negative pi over 4 for that. How about tangent inverse negative 1? 5, 4, 3, 2, 1. That's right, negative pi over 4. Because tangent is negative over here and over here. This is outside of the restriction for inverse tangent. This is in the restriction, and I can only get there by going this way. Okay, how about this one? Cosine inverse 1/2. 5, 4, 3, 2, 1. And that's going to be pi over 3. Sine inverse negative 1/2. 5, 4, 3, 2, 1. Negative pi over 6. Right, that negative. I can't get there by going this way. It can't be 11 pi over 6. I get stopped here. Can't go the rest of the way. So I have to go in this direction, which is why I have negative pi over 6. Okay? Now, how about something like this? Cosine of cosine inverse of root 3 over 2. Now my question is, does the function and its inverse just cancel each other out? Well, let's go the long way and figure this out. What angle has an x value of root 3 over 2? Well, I know that to be pi over 6. And then let's do the cosine of that angle. The cosine of pi over 6 is root 3 over 2. So yeah, in this case, I can just cancel them out. Okay. So, but if you're not sure, go the long way and figure it out. So what can we do here? Cosine inverse of negative root 2 over 2. Can we still cancel these out? 5, 4, 3, 2, 1. I get negative root 2 over 2. And here's how I did it. What angle has an x value of negative root 2 over 2 within the restriction for inverse cosine? That would be 3 pi over 4. And now I want the cosine of that angle. And sure enough, that's root 2 over 2. So crossing those out works just fine for me there. How about this one? Sine of sine inverse root 2 over 2. Okay, so 5, 4, 3, 2, 1. Yes, that's going to be pi over 4. No, it isn't, silly you. That's going to be root 2 over 2. And yes, I can cancel these out. Let's just confirm that. What angle has an upness of root 2 over 2 within the restriction? That's pi over 4. And then I want the sine of pi over 4, which is root 2 over 2. Okay, how about this one? How about sine inverse of sine of pi over 3? So in the last few problems, we had the inverse trig function on the inside and the trig function on the outside. In all those cases, I was able just to cancel out the function and its inverse. Can I do that here as well? Well, let's take a look. Sine of pi over 3 is root 3 over 2. What angle within the restriction has an upness of root 3 over 2? Oh, well, pi over 3 does. So, yeah, it looks like I can just cancel those out here as well, doink, and get pi over 3. Okay, so how about sine inverse of sine of pi over 6? 5, 4, 3, 2, 1. And that's pi over 6. And sine inverse, oh no, we moved on to cosine. Cosine inverse cosine 7 pi over 6. 5, 4, 3, 2, 1. The answer is not 7 pi over 6. It's 5 pi over 6. Who can explain why? Let's go the long way and see. The cosine of 7 pi over 6 is negative root 3 over 2. Cosine inverse. Now we're asking the question, what angle within the restriction, remember our restriction is 0 to pi, has an x value of negative root 3 over 2? 7 pi over 6 is not within this restriction. This is 6 pi over 6. That's 7 pi over 6. That's not inside this. So I can't just cancel these out. I have to, in fact, go the long way, figure out this is negative root 3 over 2, and then say what angle has an x value of negative root 3 over 2. We know that answer to be 5 pi over 6. And likewise, if I saw something like sine inverse of sine of 3 pi over 2, I can't just cancel these out. The answer is not going to be 3 pi over 2. 5, 4, 3, 2, 1. What is the answer going to be? The answer is negative pi over 2. What's the y value at 3 pi over 2? Negative 1. What angle within the restriction has a y value of negative 1? Well, within the restriction, negative pi over 2 does. Not 3 pi over 2. That is not within our restriction. Okay, so when can I cancel these out? I can always cancel unless the given angle is outside the restriction. So if I have a problem like sine of sine inverse of 1 negative 1/2, then this isn't an angle, because what I plug into an inverse trig function is an x or a y value or a tangent value. This is not an angle. And it's only if the given angle is outside. So those can cancel. It's this situation where I'm given an angle where I have to be really careful. Is this given angle outside the restriction? No, pi over 6 is within the restriction, so I can cancel. But if I'm given an angle, and that angle is outside of the restriction, then I can't just cancel. I actually have to go the long way to figure out what the answer should be. The y value at 11 pi over 6 is negative 1/2. What angle within the restriction for sine has a y value of negative 1/2? This one does. Okay, so that's the end of round 3, or 2, round 2. Let's take a look at round 3. Sine tangent inverse of 3/4. Okay, so how do I do that? My opposite, my adjacent, opposite, adjacent. I'll use the Pythagorean theorem to find the missing side. And now, this asks what angle has a tangent of 3/4? This angle does. See, this angle has an opposite over adjacent of 3/4. So what angle has a tangent of 3/4? This one. What's the sine of that angle? And the sine of that angle is opposite over hypotenuse, or 3/5. Okay, that's how these problems are going to be working. I recommend drawing a triangle. All right, secant sine inverse of 5/13. 5, 4. What do you mean that's too fast? I'll go a little slower. 5, 4, 3, 2, 1. 13 over 5. Okay. Next, tangent of cosine inverse of negative 3 over 4. 5, 4, be careful with this one, 3, 2, 1. I hope you drew the triangle. Cosine is negative over here. Remember, cosine is negative 3. The hypotenuse is 4, so this must be root 7. And then the tangent in this picture is root 7 over 4. Okay? How about sine of cosine inverse of 2 over 3? 5, 4, 3, 2, 1. Did you get root 5 over 3? Let's draw a triangle. Let's see. 2, 3, square root of 5. Sine is opposite over hypotenuse. Yep. Root 5 over 3. How are these problems different if I give you this? Sine of cosine inverse of x. By the way, it may be useful to you to write x as x over 1. Well, this is the same sort of draw a triangle situation. Adjacent, hypotenuse. I use the Pythagorean theorem to find the missing side. What's the sign in this picture? Root 1 minus x squared over 1, or just root 1 minus x squared. Okay? So we're still going to be drawing triangle. We're still going to be using Pythagorean theorem to find the missing side length, and then we're going to be evaluating our trig ratio. So how about sine of tangent inverse of x? Okay, try that one out. All right, so what's our triangle look like? It's opposite over adjacent, so adjacent must be 1. This is the square root of x squared plus 1. And now I'm looking for the sign. The sign is x over square root of x squared plus 1. Okay. Do you need me to show you how to get that? Just in case. Question mark squared equals x squared plus 1. I take the square root of both sides. Question mark equals the square root of x squared plus 1. Okay? Not the square root of each piece. It's not going to be x plus 1. I have to take the whole thing together. All right, how about this one? Tangent cosine inverse x over 3. Five, 4, 3, 2, 1. Did you get the square root of 9 minus x squared over x? Let's just check and see. Cosine is adjacent over hypotenuse. This is square root of 9 minus x squared with the Pythagorean theorem. And tangent is opposite over adjacent. Okay? Last one. How about the cotangent of tangent inverse of 1 over x? Okay, so we know Tangent is opposite over adjacent. So this is x squared plus 1. And what's the cotangent? Oh, wait a second. I didn't need to use the Pythagorean theorem here, because cotangent is just the adjacent over the opposite. Duh. Okay. Well, good job today. Give yourself a crown if you engaged with these problems and got most of them correct. If you didn't get most of them correct, it signifies that you probably need to spend more time practicing your unit circle values, so get on that. Remember, assignment 18 is textbook work, so you're going to find these scanned pages in our Office 365 team, and then you'll be able to do your homework. Yay, you! All right. Have a great day, everyone.